Hello, Honors Algebra 2. I wanted to clarify and expand a few points that some questions came up with students. Again, it's an optional video. It's a little extra. All of what I'm going to say is in the book, but if you want a video explanation with a couple examples, here you go. And I'm going to go over some vocabulary mostly and a little bit of advice for setting things up. So solving systems of equations. We had three methods: substitution, elimination, and the graphical approach. And elimination was the linear combination approach. The vocabulary that's in the book, and I want to emphasize that here, is that the idea of a consistent system. Consistent systems are systems of equations that have at least one solution. They could have one, they could have infinite. We saw both cases in class. If a system of equations has infinite solutions, that means it's a dependent system. And I'll explain that in the context of an example in a moment. Inconsistent systems are systems that have no solution. We saw that with parallel, distinct lines that never intersect. Okay, so to some examples. So this is the example we did in class, and I'm not going to redo it here, but I want to talk through some points. The substitution method was when you rearrange one of the equations to isolate one of the variables, like you can isolate x in this equation, and it allows you to substitute this in for x in the other equation. Okay, that gets rid of the x variable and allows you to solve for y. And you use that y value to plug it back into either equation, and you can solve for x. And in this case, there's exactly one solution. So the only solution is the point 3, 4. So this is a consistent system. Another method for solving this is using a linear combination or elimination. And the way we did that, there's multiple ways you could go about it. You could multiply this first equation. You could multiply this first equation by 10 on both sides. I chose to multiply the first equation by -2 just to keep the number smaller. But the goal is, so I multiplied this whole equation by -2. And you'll see that result here. Multiply both sides by -2. The goal is to get one of the variables to have the same coefficient with opposite sign so we can add them together. It's a good habit to make it so that they have the same value with opposite sign. So 6 and -6 in this case, because when you subtract equations, sometimes you'll make minus sign errors. So I'm trying to help you avoid common errors. When you add these two equations together, you add like terms vertically, and it's good to line everything up. -6y plus 6y is 0. -2x minus 10x is -12x. -30 minus 6 is -36. And we get x equals 3, plug it back in and get y equals 4. It is exactly the same thing we got in this example. Now, in case, on the graph method, you can graph this in lots of different ways. One way is just to rewrite these in slope-intercept form, and that's what I did down here. I rearranged both equations to get y by itself, and I just quickly graphed them, one in red, one in blue. They are clearly distinct lines. They are not parallel, so they intersect at exactly one point, and the coordinates of that point is exactly 3, 4, the same solution we got algebraically above. So again, this is a consistent system with a single solution, so it's not dependent. All right, here is a system, and if we solve this by linear combination, again, multiple ways we can do this. We can multiply this equation, multiply both sides of this equation like equation number 2, multiply both sides by 2. So I'll just put times 2 on the second equation. And we would get 4x minus 10y equals 18. And negative 4x plus 10y equals negative 18. And now if we add vertically, we get 0 equals 0. Now this is true. But it's true. So how do we interpret what that means? So it's true. This means that the two equations are in fact the same equation, well, equivalent equations written in different forms. So these are in fact the same lines. The same line. This is two ways of writing the same line that are overlapping. So there are infinitely many solutions. Now, so this is a consistent system. This is a consistent system because there's at least one solution. Now there happens to be infinitely many solutions. And so there are infinite solutions. One way to describe them all is with set notation. It's the set of all points in the plane that satisfy the following equation. 4x minus 10y equals 18. Or I could have used the other equation. You could put either one in here because remember they're equivalent. The other one's nice because it's reduced, so there's no common factors between the coefficients. But if you write either one here, it's correct. Now, this is a consistent system that's dependent. So this is a dependent system. That's because the y value depends on x. X and y have a dependency between each other. So there's infinitely many solutions that, and they all must satisfy this equation. So this is a dependent system. It's a consistent system. There's infinitely many solutions. Graphically, it looks like this. Both equations give the same line. It's actually the same line over the top of each other. Okay. On, oh, by the way, I had some students say the answer to this question was all real numbers or all points. So on the first incorrect answer, it's not all real numbers because actually we're not looking at single real numbers to solve this system. We're looking at coordinate points that solve this system. And notice the points that solve this system of equation are the points that lie on this blue line. Any point that's not on the blue line makes the equation false. The only points that make the system true are points that lie on the blue line. So just because there's infinite solutions doesn't mean every point solves it. It's only the ones on the line, not the ones off the line. Okay. System number 2, if we multiply top and bottom by, how about I'll multiply the top one or the bottom one by 3. I noticed then the y's would line up. And what would I get? I would get 6x minus 3y equals 15. And the second one would be negative 6x plus 3y equals negative 21. Okay. On the left-hand side, when I add everything up, I get 0 because they both cancel out. On the right-hand side, I get negative 6. Okay. 0 equals negative 6 is false. It doesn't matter what x and y are. Every pair of numbers is going to make this false. So this means there's no solution. And this is an inconsistent system. it also means the lines are parallel. Oops. And if we look at the lines down below, you will see that the two lines are parallel. They in fact have the same slope, but they are distinct lines. Okay. All right. I want to say just a bit about applications. I had a question about this from a student, so I thought it was worth mentioning. To measure the speed of the jet stream, a high speed, high altitude, west to east wind, that's what the jet stream is, a weather service plane flew 1,800 kilometers with the jet stream. So they were flying, the jet stream goes west to east. So they were flying east with the wind, and the wind was a tailwind. So the wind was pushing the plane faster. And then it flew back again against the wind. The eastbound flight took 2 hours. The westbound flight took 3 hours and 20 minutes. Find the speed of the jet stream and the airspeed of the plane. Okay, so first thing is we want everything in hours. What, 3 hours and 20 minutes is 3 hours and 20 sixtieths. So 3 hours and 3 1/3 hours, or 10 thirds hours. So if we just get it into one fraction, that would be that amount of time. And here's my little helper thing. You can let R represent the speed of the plane if there was no wind, and let W represent the speed of the wind. When a plane is flying with the wind is pushing the plane in the same direction the plane is going, so the rates add. If the plane is flying against the wind is pushing, the plane's flying this way, the wind's pushing the other way, the wind subtracts from the plane's speed. So when the plane has a tailwind, the speed is R plus W. When the tailwind means it's pushing on your tail forward. A headwind, or flying into the wind, means the wind is slowing you down. So our main equation we need in this problem is rate times time equals distance. And for a lot of these rate problems and linear equation problems, it can be helpful to use a little like a little table where you have R, T, and D, rate times time equals distance. And we have the, I'll put tailwind and headwind. Not headwing. Oops. Headwind. They said that so we don't know the rate of the plane and we don't know the wind, but when it's flying with the wind, the rate that the plane is flying is R plus W. But they did tell us that the eastbound flight with the wind took 2 hours and it flew 1,800 miles. And the westbound flight against the wind with a headwind was R minus W, and it took 10 thirds hours and 18, and it flew the same distance. This gives us a system of equations which I will let you solve. And the solutions will be available in our shared drive. But I had some questions from students not understanding the headwind and tailwind and east and west, and the question wasn't 100% clear on that. So that should help you get started. When you're setting up a system of equations like this one says the total cost of 14 gallons of regular gasoline and 10 gallons of premium gasoline is $46.68. Premium cost 30 cents more per gallon than regular, what's the cost per gallon of each gasoline? You should always start out by writing down variables for what you don't know. And they're saying, what's the cost per gallon of each type of gasoline? Make variables. So you could let premium be P in dollars per gallon. So the cost rate is in dollars per gallon. And you could let regular be R in dollars per gallon. And then try to use that to make different equations. 14 gallons of regular and 10 gallons of premium cost this total. So that means 14 gallons times R. So this would be the amount you pay. This is the dollars you pay for regular. 14 gallons times R, dollars per gallon, is the amount of money that it will cost you. And we can do the same thing for premium, and that would be 10 gallons of premium at the rate of P dollars per gallon. And that gives you the amount you paid for premium. And we know that this total, the amount for regular and the amount for premium, added up to $46.68. They also gave us that premium costs this much more per gallon than regular. So we know we have premium and regular are not equal. Which one's more? Premium is more. So in order to make them equal, we need to add 0.3 to the right-hand side. You can check yourself on that and say, okay, if I have to add 0.3 to R, that means P is more than R. Okay, sometimes students will put the plus 0.3 on the wrong side. Okay, this seems like a great place to use substitution because we can substitute this equation in for P there, or substitute the expression on the right-hand side in for P there. Okay, I will let you try these, and I'm not going to do them right now. I want you to go try them. I do have one hint on this. There's actually two ways to do this. One thing you can do is you can substitute 1 over u for 1 and 1 over v, replace those with x and y. You can also just solve these directly. For example, what if you multiply top and bottom of this by 5 and multiply top and bottom of this by -3? I would get 15 over u minus 20 over v equals 20. And I'd get -15 over u plus 18 over v equals -21. Can you see now if I add those equations, the terms with u will cancel out. I'll only be left with terms with v. So I'll only have the v variable. I can solve for v, sub it back in for u, and you're all done. Okay, on this one, it's a good thinking question. This is a good honors level question. Try to solve the system generally with A, B, and C, and D. And see what happens, and see if you can figure out which conditions would need to be placed on the constants, on the coefficients, A, B, C, and D, in order for the system to have a unique solution. In other words, so that the system is consistent and has exactly one solution. All right, that's all I'm going to say for now. I'll see you in class.